Okay. We actually saw a little bit of factoring already, but not what we're going to do. So we're going to start with common factors. So let's call that 1, common factors. And I'll give each type a heading so that you can sort of keep them straight in your mind, what's what. So common factors is when we have, for example, 2x squared minus 2. And so there's 2 terms here. A term is separated by a plus or minus sign. There's 2 terms. And what do they have in common? A 2. And so pulling that out to the front, you write a bracket and then whatever's left. So here, if we take the 2 out, we're left with x squared, and here, minus 1. Okay, so that's taking out a common factor. Now, what's left in here may or may not be able to factor. This one can, but we're not doing that yet. Okay, let's just do a couple examples where we're just pulling out the common factor and not doing anything else. Okay, so maybe we'll put a note here. This can be factored further. But we'll do it later, okay? So I just want to put that note there, because if you're looking back through the notes and say, well, why didn't she finish that question? It's just because we're only doing common factor to start, okay? So example 2. So what can we pull out? 3 and an A. So a 3A, and then you write a bracket. So how many terms were here? 2 again. If we take the 3A out, it's like dividing. When you take a common factor out, you're dividing each one by that number. So if we take the 3A out, we're left with x squared. And it's like dividing. So if you took the 3A out, what are you left with? 2A, because it's like dividing. You're not subtracting it off. You're dividing it out. So this would be, not 2A, sorry, just 2, because the A's would cancel. 6 is 3 times 2. So all that you're left with is 2. Yep. Yeah. Okay. So it's like dividing. So factoring, what's the word factor mean? Yeah, if you're taking the factors of something, what are you finding? Yeah, you're breaking it up into what multiplies to give that. And the opposite of multiplying is dividing. So you're dividing out something, okay? That's what we're doing. Factoring is dividing out. So there's 2 terms, and what do they have in common? What could we take out? For numbers, we could take out a 2. 2 divides by both of those. And for the x, just one x, because it has to be able to come out of both. And this second one doesn't have 2 x's, so you can only take one out. And then the y's, 3. So 2xy cubed. So if you need to write it off to the side to figure out what's left, you can do that. You should get better at it as you go. But the cubes will cancel, the 2's will cancel. And how many x's do we have? Just 1 left. Minus. And then if we took it out of the second one, we'll have numbers will be what? 8 divided by 2 is 4. The x's will cancel, and 1 y left. So if you can look at it and pull it out without dividing, then you can do that, okay? Now, realistically, the ones we see are not going to be even as complicated as that, because in calculus we won't often see these things. What you're going to see more likely is something like this. And what would factor out of that? A 2 and an x, yeah. So we'd be left with x squared plus 6x squared divided by 2x is 3x. And 4x divided by 2x is just 2. And then we can factor that further, which is what we're going to do right now. Okay? So common factors is really when you have to factor something, and I'll tell you when to know when you need to factor something later, but when you have to factor something, that's the first step, is look, can I pull anything out to the front? Because that'll make anything you do later easier. Okay? So you always want to look and see, can I pull anything out to the front first? So that's common factors. So what we're going to do is factor trinomials. So a polynomial, or quadratic, okay, so a quadratic meaning squared. So the highest power is 2. And then there's an x and a constant. So examples like 2x squared plus 3x plus 1. What would a, b, and c equal here? A is 2, b is 3, and c is 1. What's A, B, and C here?
0.
No, 1. Yeah. If it was 0, if it was 0 times anything, it'd be gone, so there wouldn't be an x squared if it was 0. So 1, take the sign with it, so that would be minus 3 and 2. They don't need to have all the terms to be considered a quadratic. Just the highest power has to be squared. So what's A, B, and C here? 1. Is B -3 or C -3? C. And B would be 0 because it's missing. See, there's no x. So let's put a b in but no c. What might that look like? 2x squared plus 3x. And then do you see there's no constant term on this one? So here b is 3 and c is, or an a is 2, but c is missing. So what would c be? 0. Okay? So which becomes important when you are doing what? What do you need a, b, and c for, usually? Quadratic equation, right? So which we'll do after factoring. Okay? So these are the types we're going to factor. So what are the types? Okay, so here's the 4 types. The first type, we're going to call it a not equal to 1. Okay, so that's the type. That's what we're going to give it a name. So when a is not 1. But do you see a is 1 here? So we're going to call that one a equals 1. Okay, which are not technical names for them, but that's how I'm going to call them that, so that when you see it, you say, does a equal 1 or not? Because you do something different for both of those cases. So instead of just lumping them together and say do this, we're going to do two different types. The A is one is going to be the easy one, and then this is the hard one. This is going to be called difference of squares. Oh, difference of squares. So that's like an x squared minus a number. Okay, that's going to be difference of squares. So that's what we're going to call that type. And this type is going to be called common factor, which is what we already did. So what's the difference between type 3 and 4? So B is 0 in this type. And here, which one's 0? C is 0. Okay? So we've got 4 types. If it's got all 3 terms and A is not 1, all 3 terms and A is 1, those are 2 types. Then this one, the middle term is missing, and this, the end term is missing. Okay, so that's what we're going to do, is factor all 4 of these. All right, so we're going to start with type A equals 1. Let's see if I... Okay, so does anyone remember how to do this?
You multiply the first one and the last one and whatever adds to the
Yeah, so there's one, we're going to say times and plus over here, okay? So this is type A is 1. So 6 is your times. That's a times sign, not an X. And plus is whatever B is. So this is your 6. And 5. Okay, there we go. So what we do is this. We say, what 2 numbers multiply to give 6 and add to give 5? That's your question. What 2 numbers multiply to give 6 and add to give 5? So I want to start easy. So you have to think, so you think of the factors of 6. So what are some possible factors of 6? Do you have a question?
Yes, why does the multiplication equals 6 and the positive sign in front of 6? I don't get that. X equals, multiplication equals 6.
And add equals 5.
Yeah, but why is there a plus in front of the 6? I don't get that.
Why is there a plus in front of
It
it?
wasn't a
Where?
6, it's a,
Well, this is the equation.
yeah. What is it then that?
So you could, instead of writing the symbols, you could write multiply.
Yeah, no, I
And
understand
add.
that, but why would 6 go there with the multiply?
Oh,
when
he
you're
wants to
adding
know
6?
why it's not multiplied in the equation, if it's multiplied.
Yeah.
Okay, let's just, I'm not sure your question, so let's just hold it for a minute. I'll do the question, and then you can ask again, okay? So this is how you set it up. You take whatever C is and call it multiply, and whatever B is and you call it add. This is the technique. So this is saying what 2 numbers multiply to give 6 and add to give 5. So what are the 2 numbers that multiply to give 6 and add to give 5? 3 times 2 multiplies to give 6, and does 3 plus 2 add to give 5? So 3 and 2 So 3 times 2 equals 6, that's the multiply, and 3 plus 2 equals 5, that's the add. Does that make sense? And so what you do is you come over here, and you've got your two numbers, 3 and 2, and you could put them 2 and 3, it doesn't matter the order. And you factored. So, how do we know this is the right answer? How can you check your work? FOIL, right. When you have two brackets, how do you expand it? So this is called factoring when you go this way, factoring. If we went one more step and called it expanding, that's getting rid of the brackets, and we use FOIL to do that. So how does that look? So first times first, x times x is x squared. Outside, that's the 2 on the outside, so x times 2, 2x. Inside, 3x. And last, 6. These were two numbers that multiply to give 6, and those same two numbers add to give 5, whatever's in front of the x. Yep.
Can you do the last step first and then like
Yeah, yeah. Yeah, that's called grouping. We're going to do that technique with A is not 1. Now this is just a check, so this is not part of the answer. This is just a check. Multiplying it out is going back to the start. That's not what you want to do. You don't want to do that. You probably won't even do it if you're confident with your answers, that those two numbers are the right two numbers. But if you're not confident, which happens sometimes when there's negative signs, if you multiply it out, you say, did I get back to where I started? Yes. Okay, I've got the right factoring. So the actual answer for that question would be what? So the question would say, factor x squared plus 5x plus 6. And you'd say, okay, what two numbers multiply to give 6 and add to give 5? That's 3 and 2. So this would be x plus 3, x plus 2. And that's it. So the actual expanding after is just checking to make sure that you got the right numbers. Yep.
If A was x to the power of 4, would it be x squared in each bracket?
Yeah, but we'll do that later. Yeah. Okay, so the next example. Let's keep the signs with plus for another example, okay? Because they get more complicated when we do minus. So x squared plus 9x plus 20. So we want to find the two numbers that we put in here that will what? Multiply to give 20 and add to give 9. So we have to say, and you always start with the multiply because that's going to be easier. So there's lots of things that add to give 9. But multiply to give 20, there's only a few things that multiply to give 20. What are some options? 4 and 5. Yeah, 20 and 1 do multiply to give 20. Right? Say you said 20, okay, the numbers are 20 and 1. So they do multiply to give 20, but do they add to give 9? No. They add to give 21? Yeah. Right? So if the middle number was a 21, then that would work. But it's not. What are the answers? 4 and 5. So 4 times 5 is 20, and 4 plus 5 is 9. So you just go over here and you say one of these numbers is 4 and one of them is 5, and that's your answer. And if you wanted to check, you weren't positive, you would just FOIL it out. You would get back to where you started. All right, let's add some negatives in here. So we want these to multiply to give what? Always take the sign with it. Your A, B, and C include the sign that's with it. So multiply to give negative 2, and add to give what's in front of the x? 1. Now, when you're trying to figure out what multiplies to give a negative number, forget the negative. Okay, just think of the number 2. What numbers multiply to give 2? 1 and 2, and that's it, right? 1 times 2? Nothing else multiplies to give 2. So the question here, even though we put a plus sign, when there's negatives involved, it could be subtract. So the question really is, what two numbers multiply to give negative 2 and add or subtract to give 1? Okay, so you can think of it as subtracting as well. So these two numbers, right now it just multiplies to give positive 2, but we'll worry about the sign in a minute, okay? When we add them, what do we get? 3. When you subtract 2 and 1, what do you get? 1. Don't worry about the sign, okay? But 2 minus 1 is 1. 2 plus 1 is 3. That middle number, either for these two to work, the middle number either has to be a 3 or a 1. Either add them or subtract them. So is that a 3 or a 1? It is. It's a 1. Was that adding the numbers or subtracting? Subtracting. So which one do we subtract to give a positive 1? It would have to be 2 minus 1 is equal to 1. And what I mean is, is it 2 minus 1, or is it 1 minus 2, which would be what? Negative 1. So you have to decide which way do I subtract them to get what I want. And what I want is a positive 1, so I have to do 2 minus 1. So that means, go back up here, which one has a negative sign in front of it? Is it the 2 or the 1? The 1, because we had to subtract the 1. So this is minus 1 times 2. Those are your two numbers. Minus 1 times 2 is equal to minus 2, and 2 minus 1 is equal to 1. We'll do it again. So what are the two numbers? A minus 1 and a positive 2. And if you FOIL it out, you'll see that you got the right thing. Okay, but you have to watch the sign. So let's put another negative. X squared plus x minus 6. So set up your times and your plus. So we want to multiply to give negative 6, and we want to add to give plus 1, or just 1. So what are some options? 6 and 1? We want to multiply to give 6. And remember, don't worry about the sign. That'll come when you add. So 6 and 1. What do they add to? 7. And what do they subtract to? 5. Is that a 7 or a 5? No. So that one's a no. What are some other options? What multiplies to give 6? 2 and 3. So they add to give 5, and they subtract to give 1. Is that a 5 or a 1? Yes, it is a 1. So how do we have to set these two numbers up to give us a positive 1? 3 minus 2. We don't want to add them. And we want it to equal positive 1, so we have to have the bigger number first. Right, the smaller number would be first if you subtract. So these tell you the signs for up here, because this will be a plus 3 times a minus 2. There's the minus goes with the 2, and the plus goes with the 3. So that gives you minus 6, and it adds to give 1. So plus 3 and minus 2. And again, I said these could go in either order, like there's no right or wrong way, and there's no standard way, so it doesn't matter if you put the minus first or the plus. Okay, that doesn't matter. All right, so let's do another one with a minus.
Can you explain that one again?
Yeah. Explain what I just said here, or? I just said it doesn't matter, like if you wrote it this way.
No, not that part, the
Oh.
last step before that.
So once you find your numbers,
Yeah.
you just put them in. Yeah. So we found that 3 minus 2 is 1, and 3 times minus 2 is minus 6. And then you just write the 3 and the minus 2 in. I'll do another one. Okay. All right, harder. X squared minus 10x plus 24. And maybe it's not harder, but maybe it is. Okay, so what do we set up first? The times and the plus? So what do we want them to multiply to give? 24. And we want them to add to give negative 10. So start with the 24. So what two numbers multiply to give 24? 4 and 6, 12 and 12 times 2, 4 times 6. Oh, 3 times 8. Anything else? 24 times 1. That's not usually the answer, but it is possible, right?
Yeah.
So how do you know which set of two numbers it is? You have to add them and subtract them and see which one works to your middle number. So what are the two options for this first? If we add them, we get 14. If we subtract them, we get 10. So is there a 10 there? Yeah. So this might work. If we add these, we get 10. If we subtract them, 2. So this might work. There's two options so far. What about these two? If we add them, 11. That's not going to work. And subtract them, 5. So that one's out for sure because we need a 10. And this one, add them, 25. So no. And subtract them, 23. So that one's out. Okay. So there is two options. Now we have to try them to get the right sign with the multiply and see which one works. Okay, so let's try 12 and 2 first. So we have a 12 and a 2. We want to multiply them to get 24. And we want to add or subtract them to get minus 10. So how would they subtract to give, or add or subtract to give minus 10? Which sign has to be which?
2 minus 12.
Yeah, it has to be 2 minus 12, or minus 12 plus 2. The minus sign has to be on the bigger one because we want more negative left, right? If it's minus 12 degrees out and it goes up by 2 degrees, you're still in the negative, right? So more negative. So that gives us minus 10, which is what we want. But why doesn't it work? So when you go back up here, you say, okay, that's the way it works. So now if we put that sign up here and we multiply these two, what do we actually get? Minus 24. That's not right. But there was another option with the 10. So let's try it. So this was the 2 and 12. So we want to try 4 times 6 to give 24, and 4 plus or minus 6 in one of them plus, one of them minus, both, or whatever, to give minus 10. So we start with your plus once you get your factors. So how could we combine these to get negative 10? Yeah, negative 6 and negative 4, both negative. Because if you're at negative 4 degrees out and you go down 6 more, you're now negative 10 degrees, right? 2 negatives. So it goes down negative 10. Now, if these are both negative, what do you get? Positive. So this works. So the numbers are negative 4 and negative 6. So negative 4, negative 6 work. And again, like if you weren't sure with your signs, FOIL it out and you should get back to what you started with. If you don't, you probably picked the wrong one. Because at a first glance, you could say, oh, 12 and 2, that gives 10. Put them in and you put the wrong signs. If you FOIL it out, you'll notice that it didn't work. Yeah?
What happens if they don't work?
Then it doesn't factor.
Okay, so you could say like no solution, or not factorable?
Right. It depends what the question is. So we're going to use factoring for something else.
Okay.
So if we were solving for x, we'd actually then jump to the quadratic equation if it doesn't factor. Yeah. So it's not that there's no solution usually. It's just that you can't find it by factoring.
Okay.
Yeah. Okay. So, yeah, whenever you see a quadratic and you're trying to solve for x, which we're going to do later, you try to factor it. If it doesn't factor, then you say quadratic equation. And does the quadratic equation always work? No, because you can't have a negative under a square root. It's got a square. So there could be no solution, but it could be that it works just not to nice numbers. Factoring only finds the nice numbers that work, right? We're not doing like 0.3 and stuff like that. Yeah. Okay. Factor x squared minus 4x plus 3. Okay, so we need two numbers that multiply to give 3 and add to give 4. So what are they? The only thing that multiplies to give 3 is 3 and 1, so that's the only option. So it has to be 3 times 1 is equal to 3, and 3, I'm just leaving the signs out, it has to go, minus 4, right? So it has to give minus 4. So how would the signs have to go? You have to add them, so either both signs are plus or both signs are minus. We want to give a negative.
Negative 1, that's 3.
Yeah, exactly. Both negative will give a negative 4. Now, what do you do once you do that is you go back to the start and try it with the signs. Make sure it actually multiplies to give. So you put your signs up here and say, do these give me a positive 3? Yeah, so that's my numbers. Minus 3 and minus 1. Okay, two more like this. So we want to multiply to give 9 and add to give 6. Both are positive, so it will be easier. There won't be negatives involved. So two numbers that multiply to give 9. 3 and 3. And 3 plus 3 gives 6. And this is just to show that they don't have to be different numbers. Right. So how would you write this? Yeah, so not square each, you would square x plus 3 squared. So whenever you see a bracket squared, to FOIL it out, you have to write it as 2 brackets and then. Mhm. Oh, this one?
No,
This one?
they won't end at 9.
Right.
Oh, right.
Okay. Yeah, and so remember, like, one thing I showed you before is when you have this, when we were doing exponents, what do you not do here? Yeah, do not do x squared plus 3 squared. That's very wrong. That doesn't give you the right thing. What you do is you would write it out twice and then you FOIL it. And that gives you the 3 terms. Okay, so be careful of that. And we talked about that with exponents, that whenever you have a bracket, a square root works too, or squared or anything. You have to write the bracket out and then FOIL it. Yep.
If you have two the same, you have to write it as a square.
You don't have to, no. No, if you left it like this, it's fine. But you'll often see this written, and that's what it means. Okay, that's called a perfect square, not that it matters what it's called. Okay. But it's called a perfect square. It actually has a name. Okay. So this one. 2 numbers that multiply to give -10 and add to give -3. What do you think? 2 numbers that multiply to give 10. 5 and 2. 5 and 2. So how would they have to be the signs to give a -3? -5 plus 2. That'll be more negative. And if that's -5 times 2, that gives me -10, so that works. -5 and plus 2. Factor. Yeah. So I made the test up already, and I put factor, and there's 4 questions, 1 of each type. That's what's on the test. So this is 1 type. But we already did 2 types because we did common factor. Common factor, pulling out a common factor.
I thought this was type A.
This is type A equals 1, but we did common factor first.
We've done 2.
Yeah. And next class we'll do 2. No, that's from this section. Yeah. Yeah, there's solving equations with radicals, there's solving equations with fractions, there's absolute value, there's inequalities. Is there what? Yeah, we're doing that Friday. Yeah. Okay, so what about this one? So we want to multiply to give 7 and add to give 6. So what multiplies to give 7? 7 and 1. Now we want them to add or subtract to give 6. So how would that work? 7 minus 1. So if we put the minus sign up here on the 1, then what happens? That gives -7, not +7, but we want it to be +7. So what do you do? Is there another option that we missed? Anything else multiply to give 7? No, so there's no other option. And the one option we had didn't work, so this doesn't factor. doesn't factor. It doesn't mean there's no solution, because we're gonna use this for other things. It just means you can't write it as a product of two binomials. Doesn't factor. Okay, so even though it looks close, like it might factor, because you can get the two numbers, how could we rewrite this that it actually did work? What would make it work? Yeah, if I had this 7 as negative, it would have worked. Whoops. Because then 7 minus 1 is positive 6, and 7 times minus 1 is minus 7. So that would actually work.
Or if you had 7x, right? Or 8x.
Yeah, yeah. So what he's saying is, what if we had 8x instead of 6x? 7 and 1 add to give? Right? 7 plus 1 is 8, and 7 times 1 is 7. Okay, so next class what we're going to do is the type that A is not 1, that's harder to do.